The complex trinomial method for factoring is similar to the simple trinomial method, but it can be used in situations where your a, the numerical coefficient of the first term, is not 1. In both of these cases, we have a numerical coefficient of the first term that is not 1. So let's try using the complex trinomial method to factor them. The first step is the same. Define your a, your b, and your c. In this case, a is 6, b is -5, and c is -4. Now we have an extra step. What is AC? A times c is 6 times -4, so AC is equal to -24. The question we ask is a little bit different. Now we are saying, what two numbers multiply to give AC -24 and add to give B -5? The two numbers that multiply to give -24 and add to give -5 are -8 and +3. So we write those, 8, -8, and 3. Now we rewrite our expression so that instead of -5, we write both of these numbers in a bracket. It looks like this. 6x squared plus 3 minus 8, I like putting the positive one first when I have a positive one, x minus 4. Now the special things to notice about this are the two numbers that I found as an answer to my question are inside the bracket. Everything else looks the same as it did on the outside of the bracket, except this sign, if it's a minus, has to turn into a plus. Always make this a plus. The next thing I'll do is I'll break this 3 minus 8x into two separate terms. I get 6x squared plus 3x minus 8x minus 4. And what I have done is I have converted my complex trinomial into a 4-term grouping. If I already know my grouping factoring method, I can finish this off quickly. The greatest common factor of 6x squared and 3x is 3x. And if I factor out the 3x, I get 2x plus 1. The greatest common factor of -8x and -4 is going to be -4. And if I factor -4 out of these two terms, I get 2x plus 1. As I expected in a grouping, the contents of the brackets are the same. Now I can rewrite this 3x minus 4 times 2x plus 1. This is my answer. If I multiply these two binomials together, I will get the original expression. The complex trinomial method is similar to the simple trinomial method at the beginning, and then partway through, it starts looking more like a grouping. But if you know those two methods, it's still easy, and it will always work. Here's another example where the only complication is we have that extra letter. We have the q and the q squared involved.